Yeah. My body is so bad.
Yes.
I don't know.
Great, make sure you all sign this and sign sheets up here. All right, welcome back. So this is week 4.
I will blame you.
I apologize, last week slides said week 4, so that was just 3. Okay, so before we start with this week's topic, I'll just do a quick summary of what we talked about last week. We talked about within the category of testing for differences, we talked about the difference in comparing existing groups and comparing manipulated groups, and the different challenges for internal validity or causal inference between those two kinds of designs. So when you're comparing existing groups, the biggest challenge for internal validity is that there could be other causal explanations. It doesn't have to be X causing Y, it could be Y causing X, could be other variables causing both X and Y. It's really, really hard to make strong causal inferences. It's rare that a strong causal inference, a strong conclusion about cause and effect would be warranted when you're comparing existing groups, but there are some sophisticated techniques that people can use to get closer and closer to that. When you're comparing manipulated groups, you're on more solid ground for making a causal inference, because the manipulation, if it's done well, should help to rule out the reverse causality and third variable threats, but there are still some threats. So if the manipulation isn't perfect, there could be confounds, and there could be selective attrition, which can affect causal inference. Make sure you understand the logic behind that. We also talked about other kinds of validity threats for when testing for differences with both existing groups and manipulated groups. We talked about statistical validity threats, false positives, false negatives, getting the effect size wrong, or even the direction of the effect wrong. And then we talked about external validity is less of an issue when comparing between groups, but it's still relevant. Whereas when we're generalizing to populations, we talked about the biggest threats being external validity and statistical validity. There's usually no issue with internal validity because there usually aren't causal things when you're talking about one variable at a time. There's no effect of one variable on another. And with external validity here, it becomes much more important to have a representative sample. For statistical validity, it's really important to have a large sample. Then we talked about the trade-off between it. If you have to choose, a representative sample is more important than a large sample. Of course, choice is always better. And then, of course, we didn't talk about construct validity for any of these designs, but it's always important. It's always really important that your measures and manipulations be valid. If you're coming in, make sure you sign in on the sign-in sheet at the back of the room. Okay, any questions about the content we covered last week? It's a very, very quick summary. The recording's also online, so that should help you review the material. Okay, so just as a reminder, these are the 4 validities in the framework that we've talked about. We haven't talked much about construct validity because you covered some of that in the week on survey design. But remember that it's always really important. If you're not measuring or manipulating what you think you're measuring or manipulating, your conclusions won't be valid. A few more things on this before we move on. So there's a couple of useful websites for figuring out how many people you need in your sample, how large of a sample you need, your sample size, especially in the context of generalizing to populations. So these websites help you figure out how much precision you'll have. So if you want to know within a margin of error, you specify, how precise you need to know the answer, and it'll tell you what sample size you need based on a few other things you tell it. Okay, so this week we're going to talk about evidence review, and there's going to be 2 parts: a shorter part on just searching the literature, and then a longer part on evaluating the literature. So for this first part on searching the literature, I'm going to use some slides that are from the UniMel website. I think it's the libraries that put these together on how to do systematic reviews and other kinds of reviews, tools and tips for researchers. This is the website where you can find more. So I used some of their slides, not all of them, and I modified some, so you'll see some differences. But if you want to see the full presentation, it's there. Okay, so if we're interested in doing a literature review, let's say we're interested in a particular research question and we're not going to collect new data on it, we're just going to go and look at the literature and summarize the literature. And let's take an example. So let's say we're interested in generalizing populations, so looking at one particular variable at a time. In this case, the variable we're interested in is sexting, the frequency of sexting. So there's already a systematic review of this topic from a few years ago. And in this systematic review, we found 25 studies that had a prevalence measure, so a measure of how prevalent sexting is. And there was lots of variability in the age range of studies, so they decided to group the studies because they thought that it might be very different for adolescents versus adults, so those numbers would be at least be interpreted differently, have different implications, for example, legal implications. And so this is the range of prevalence estimates across the 12 studies using adolescents. They mentioned that 6 of those 12 studies had random or representative samples. It's kind of surprising to me, as we talked about last time, it's quite hard to get an actually representative sample. My guess is that these are representative-ish samples. It's, again, very rare in modern times to get representative, truly representative samples. But maybe they used weighting or other ways to get closer to a representative sample. So these are the ranges they estimated across the different studies for how frequent, what proportion of people have sent or received sex messages. And then in 13 studies, they found with adults, here they don't provide a range, they provide a more specific estimate. 53% have sent one and 56% have received one. And here they specified that of these 13 studies, 9 were with undergraduate student samples, who tend to be obviously very young adults. So that is a big caveat in how we would interpret those results. So there's already some things that they've highlighted that you would want to pay attention to. So whether it's an undergraduate sample or not, whether it's a representative or representative-ish sample or not. But we'd also probably want to know things like the sample size for these studies, their measures, right? So the construct validity of the way they asked about sexting. Did they take steps to make sure that people felt comfortable responding honestly? How they recruited participants and whether that process might have introduced selection bias, which would affect external validity, right? If the participants opt in and there's any reason to think that the types of people who would opt in might be different than the types of people who would not respond to the invitation. That introduces selection bias that affects external validity. Okay. So those are just some examples of things we would want to know about each of the studies, and we'll come back to that in the second part of the lecture. So systematic reviews is one kind of review. There's also different languages that different people in different fields use for different types of reviews, but here they're grouped into traditional reviews. So narrative, critical, and intuitive reviews are more qualitative, and they more, as narrative implies, they're more about just telling a story, giving a big picture overview of the literature. Systematic reviews are more quantitative. Often you might have heard of meta-analysis. The readings were specifically about meta-analysis, but the reason I picked those 2 blog posts as readings for this week is not so much, I'm not going to cover meta-analysis much. You're not going to learn how to do meta-analysis in 1 week. But the examples in the blog posts gave a really good example of like how to critically evaluate individual studies in a review. And that applies to any of these kinds of reviews. And there are other words that are not up here that you'll hear too. Okay, so what does a timeline look like for doing a systematic review? This is a particular kind of review, and this is a very idealized process. You won't always have time to do all of these steps thoroughly, but there's a few things that are really, really crucial. So first, it's really important to define your research question and scope. So you might know what your research question is, and it's about, the prevalence, say, of commuting by bicycle to work. Are you interested in just one city, just one region? Are you interested in just adults, just people who work outside the house, et cetera? So defining the scope is really, really important. You should think about how strict you want to be about the relevance of studies. So if you find studies that are not directly relevant, how are you going to incorporate those into your review? Are you going to weight them by their relevance? Are you going to just use your subjective judgment, which is fine? There are many advantages and disadvantages of more quantitative versus more qualitative approaches to reviews. And I would say that it's actually probably riskier to take a strictly quantitative approach where you don't inject your judgment into it at all. You just take a mathematical summary. The blog posts that I assigned for this week actually get at that. And if you poked around their website, they have other posts about meta-analysis that are more about this issue of like mixing averages of very different things together and the meaninglessness of that. So you definitely do want to give yourself room to use judgment about the relevance of the study and how much it should be included or weighted. It's really good to have as clear of an idea ahead of time about your protocol, which is exactly what you're going to do. So deciding ahead of time your scope and your inclusion criteria and so on. And also, are you going to quantitatively average the effects across the studies, or what are you going to do? And one of the reasons that it's important to do is for the same reason that we talked about pre-registration last week, is that if you leave things too open, you give yourself a lot of flexibility, and then motivated reasoning and biases can come in, and you can convince yourself that, oh, this study is really not relevant, but actually you're telling yourself that because the result of the study is not what you want to believe or what you want the conclusion to be. And so the less you give yourself flexibility to do that, the better. Of course, that goes against what I just said about using your subjective judgment as you're evaluating each study. And it's just so hard to balance those things, but both are really important considerations. So consider what you can commit to ahead of time that will leave you less room to be biased and let your motivated reasoning affect you, so that you can't throw out a study or decide not to include it just because you don't like the results. But you also have to give yourself enough room to evaluate if a study has serious validity threats and shouldn't be included, maybe even for a reason you didn't stipulate ahead of time. So lay out as many of the reasons you could think of that you will or won't include studies, or how you'll evaluate them. Try to be as explicit about that ahead of time in your protocol. But again, if there's a case where your judgment is strongly in a different direction, it's okay to deviate from that plan. You just have to disclose that you did that. And especially, I think in reviews, it's really, there's going to be things that you didn't anticipate that come up. Then planning the search and selecting the databases. So think about what search terms you want to use. This can be challenging because you might not be aware that the same concept goes by a different language in different fields or subfields. So it's important not to just use what comes to mind easily, because there could be systematic differences between the literature that uses those search phrases and the literatures that don't. Same thing with databases. It's important to think about different databases to search, not just go with the ones you're familiar with. Then you perform the searches, so you collect all the literature that's relevant. You keep good records of everything you're doing. So all of the records that you identify as potentially relevant, then you go through them and see if they are relevant. You're going to want to have that information handy for when you report your findings. How many papers came up that were relevant, came up in your search? How many of those did you deem relevant? And how many did you exclude after closer inspection, etc. So the screening of results is where a lot of subjectivity comes in, and this is both good and bad. And then data extraction or appraisal, that might be more or less relevant depending on whether you're doing a meta-analysis type quantitative review. But the screening of results and the data extraction and appraisal, so assessing the validity of the evidence, especially that latter step, is where a lot of the biases are most likely to come in. They can come in the search, or even defining the scope, right? You might define the scope of your question in a way that already excludes some literature that actually would be relevant but wouldn't support the conclusion you want. So that's already a place where bias can come in. Certainly how you perform your searches, bias can come in, but this might be, the most dangerous place in terms of bias. But again, the most important thing is to be transparent about what you did, so that if there was bias, the reader would have a chance to detect it. You don't rely on your own self, introspection about whether you think that you were biased, because we know that that's not a very good, often when we're biased, we're not aware of it. Okay, so as I mentioned, it's important to search more than one database. These are some examples of databases. This is kind of oriented more towards medical research. These would be the most relevant in that scope. But also now Google Scholar is a really, really important one. It wasn't on the website slides when I downloaded them. They might have updated them since then. But I would also include Google Scholar as a database to search. And there's evidence showing that when you search the same keywords and same scope in different databases, you get non-overlapping search results. So it's really important that you search different databases. Again, the library has really good guides for if you want to do a really thorough systematic review. And there's other tools as well. So you can search using these other tools. Or also another place to search is preprint servers. So these are where researchers post their research separately from publishing them in journals. So either before, sometimes after. So I might publish my research in a journal, but I know that not everybody has a subscription to that journal. So I can also, some journals allow researchers to also post a free version on a preprint server. The one for psychology is called PsyArchive, but there are many other, often they have something like archive in their name. You can also get a library card from the National Library of Australia and the State Library of Victoria that allows you to access their online databases. There are other tools that are especially useful for more applied research. So this is the Analysis and Policy Observatory that has tools to help you search for not just published scientific articles, journal articles, but also other kinds of literature that's often called the gray literature. And so this includes anything that's publicly available somewhere, but not in a scientific journal that's indexed in many of these databases. So things that are published as like government reports or white papers, guides, dissertations or theses, conference papers, working papers. Sometimes media articles will actually report new data that aren't published anywhere else, things like that. So all of that is gray literature, and that's important to include in a review, especially because if you think about what are the selection pressures operating on journal articles in scientific journals. So only some things end up getting published in scientific journals, and it's not random which findings end up getting published. It's the more exciting findings, the more statistically significant findings, the findings that the researchers were happy about, and the ones that are less likely to get published are ones that either the researchers didn't like the results or the journals themselves didn't like the result, which can often be more boring results or things that didn't work or things that didn't support the theory, etc. And so if you only search the literature in scientific journals, you're going to get a biased sample. So it's really important to make an effort to find the gray literature, things that are unpublished in the sense of like not published in a scientific journal, but still publicly accessible. In some areas, especially in the medical domains, there are a lot of norms and sometimes requirements around registering protocols, including registering protocols for systematic reviews and meta-analyses and so on. So there are templates for what decisions you're going to have to make along the way, and you fill those out and say and kind of pre-commit to what you're going to do, and you can post that to a registry that helps hold you accountable and helps readers then go and look. So similar to pre-registering a study where you're collecting new data, you can pre-register or register a protocol for a systematic review. And these guidelines that were developed mostly again for medicine might be useful, but the Prospero guidelines, for example, and there are others as well if you Google around. Prisma guidelines is one that a lot of psychologists use. Okay, so that's all I'm going to say about the other parts of doing literature review, finding the literature and so on. Now we're going to dive deeper into evaluating the quality of the individual studies that turn out. But again, it's really important that the way that you search the literature, that you put effort into finding things that are not as easy to find, finding things that might not be published in scientific journals, finding all the keywords and search terms that are relevant in different fields that you might not have heard of, and so on. Okay, so here I'm going to take a slight detour and just talk about, one of the things that we're assuming here is that many applied questions, for example, in marketing or in management and fields that you might be likely to go into, can be scientific evidence can help answer those applied questions, right? And we all believe that, otherwise we wouldn't be here, and I believe that too. But I just want to flag that that's actually somewhat controversial. So I found a few interesting papers, one about marketing, one about management, that ask about whether we should really assume that the best answers to these applied questions are from scientific evidence and from the scientific literature. So one paper from 2004 argues that the status of marketing as a science is now seriously in doubt, and it does a review of kind of reasons to be skeptical, not only that there are scientific answers to marketing questions, but that's even the right approach or the right way to think about it. So they cite another paper, Brown 1998, who described the bulk of modern marketing scholarship as, quote, a complete waste of time and effort, a wrong-headed attempt to acquire the trappings of science. Right, so the idea here is that we're trying to put like a scientific veneer on something that isn't fundamentally a scientific question. Now, again, I think that that's not, I don't agree with this for many cases of marketing related questions, but we should stop and think. In some cases, some things are not within the scope of science, and especially questions that have to do with what a company or a group ought to do, right? Moral questions. Of course, they can be informed by scientific evidence, but ultimately the moral questions and the ethical questions have to have another layer in addition to scientific evidence. Another area where I might tend to agree more with this perspective is when it's something that there isn't or can't be a lot of scientific evidence about, or where the company or group that you're helping to make a decision actually has a lot of experience, and their personal experience might be much more relevant than the little bit of, less than perfect scientific evidence. So sometimes I feel this way in my home field of social psychology, when social psychologists do research, with college students, and they do simple lab experiments, and then they go and they consult with, for example, teachers or principals of grade schools and tell them how to do their jobs. In a lot of those cases, I think that the evidence base for what the social psychologists are telling the practitioners is so weak that we should really be telling practitioners, if your intuition and experience goes against what we're telling you, then you should maybe weigh that more than what we're telling you. So one aspect of this that I do agree with is that often we put science on a pedestal, we give it a special status, and I do think it's really important to ask, is this even a scientific question, or is it a question that science can answer well and thoroughly, and is it a question that science has answered well and thoroughly, or have we done these kind of, preliminary studies that are not yet ready to be applied? So furthering this argument, the authors write that while academic chemists can make a strong case for keeping their intellectual distance from Glaxo, academic marketing researchers find it much harder to stay away from Procter & Gamble or whatever. So this is a different argument against relying too much on scientific findings from marketing in academia, and that's that the conflicts of interest are a bigger threat in this person's opinion. I actually think, again, I don't completely agree for a number of reasons. One is that I'm not sure academic chemists are that good at keeping their distance from pharmaceutical companies. Perhaps in chemistry departments, but in medical schools, it's very common for there to be strong pressure from industry on what studies get conducted, what studies get reported, how they get reported, and so on. So the authors do have a more balanced take than I'm making it look here. So they write, this is not to lose sight of the need for applied academics to continue operating as independent knowledge generators in keeping with the aims of university research. There are greater dangers in too close a liaison with practitioners. Fundamentals may be abandoned in favor of fads. Researchers may metamorphose into poorly paid consultants doing research on the cheap. To paraphrase Gray, we must remember our position in the knowledge value chain. Compared to consultants or corporate academies, universities' unique selling point is independence. So the author, raises the challenge of conflicts of interest, but reiterates the importance of still trying to aspire to that and trying to maintain independence if you're not working for the company, if you're just an academic researcher who's hoping to be helpful to practitioners, there's an important role for that. What about in management science? So this is a different paper from 2002. So again, this author expresses doubt whether management is a subject about which scientific knowledge can be had at all, and for similar reasons as the other paper. And then the author, this is actually a whole book, the author writes, the main argument of this chapter can be summarized as follows. For an idea or concept or technique to be useful, especially to busy managers, it needs to be clear and easily grasped. So it should be simply expressed and ideally have some motivating potential. Utility requires simplicity, but for something to be true about management, it needs to take account of a wide range of issues because management is an applied human study. Thus, truth requires complexity. So there's a tendency for truth and utility to go in opposite ways. The more easily understood and directly applicable an idea, the less likely it is to have a solid body of supporting evidence. The more precisely defined an idea, the more closely and soundly it is supported by evidence, the less applicable it is to general practice. And I think this is true, and something that, even academics who don't interact very much with applied domains still struggle with this, of like how much to simplify in order for people to understand your message and it to be useful, versus how much to give the full nuance and complexity of your results. And I think this is something that you're very likely to experience this tension in your future careers, especially as you have to talk to kind of both constituencies. You have to still be true to the scientific messiness of things, but also make your recommendations or summaries useful to practitioners who want to know if there's anything we can take on this. The main thing I would say, one thing I think from my perspective, and this is just my opinion, this won't be on any exams, but I think that if in this tension between utility and truth, I think that we should remember that sometimes it's okay for the answer to be, we don't know. The science isn't good enough to be a basis for decision. There are many other ways to make decisions than just based on scientific evidence. So when the scientific evidence is weak, especially because people have a tendency to put scientific evidence on a pedestal, I think it's really important to lead with that, here's the scientific evidence, but I didn't think it was very relevant or very rigorous or very compelling, or the conclusions weren't clear. So I think that we should only weigh the scientific evidence a little bit in our decision, and there are many other factors we can weigh as well. Okay. So I think, I'm gonna reject these authors' claims that maybe these questions aren't even amenable to scientific answers. I think they are. Many management, marketing, and applied practitioner questions can be informed. The decisions can be informed by scientific evidence, but I do think it's a point well taken that that's complicated and often, overhyped a bit, and people put too much on flimsy scientific results. Okay, so now we're going to talk about how to evaluate individual scientific studies to figure out if they should be weighted in our decision making, for example, or our reviews, and incorporated into our summaries and recommendations. There are some guidelines and checklists that people have developed to try to evaluate the quality of individual studies, but to be honest, I don't think they're that good. So they include risk of bias measures or reporting guidelines, critical appraisal tools. Again, these are mostly developed in the medical domain. I think they're useful in specific contexts, but overall, I think they're too narrow. So anything that's a checklist is going to miss many of the ways that research can be strong or weak. You can't really reduce that to a checklist. So unfortunately, there's no way around, again, using our judgment, using critical thinking to evaluate the strengths and weaknesses of each study. I'm guilty of this too. My students and I have created a checklist that we don't call a checklist because we don't like that idea, but a tool. It's actually a Shiny app that helps you think through the potential threats to validity of a study in psychology. It's actually publicly available now at cboat.io. I can share the link later on Canvas. So we've tried to identify kind of the biggest threats, like what would you put on a checklist if you made a checklist to help kind of researchers when they're evaluating a paper think through things, because I found that myself when I read the paper, often I'll like get so hung up on the 1 or 2 or 3 biggest problems, and then I forget to look for the other potential problems. So I found it really useful, especially in my role as a journal editor, to kind of, after I've made my evaluation, first pass my evaluation, go back and look through the most common problems that studies have and see if, oh yeah, the study also had that problem. It was just had this other bigger devastating problem, so I didn't even think to ask myself about that one. Okay, so let's, before we get into my recommendations about how to evaluate quality, I think we can reflect on what we naturally do anyway. Everyone already does this, right? When you read an article about this is good for you or this is bad for you or research shows this or that, we already engage our critical faculties, hopefully. Like hopefully everybody does, even people who have no training in science, right? Sometimes just on the face of it, even from a headline or media article, you can see something that doesn't add up or that makes you skeptical of the conclusion. And you all would have even more training in this. And in fact, the fact that we did pretty well as a class on this quiz suggests that we were using some information, even with a little tiny snippet that we were basing our evaluations on. So I'm going to escape out of here. Go back to this. So we're going to do this quiz again. We might get the same studies, we might get different studies, but this time I'm going to ask you all to point out some things that might be influencing your judgment when you decide whether something is likely to replicate or not. So this one we've seen before. Priming analytic thinking by getting people to look at a photo of a thinker makes people report less religious belief. I'm going to expand this, some details and stats from the paper. This isn't much, but it's a bit more than the headline. I'll give you a second to read that. Okay, so before we get into critiquing, why we might be skeptical or confident in this finding, let's first make sure we're all on the same page. So what's the independent variable here, the manipulated variable? Yeah.
The thinker statue versus the normal.
Yeah. So the picture that they were shown, whether it was the thinker or the other artwork, it's not the thinker. Great. And what's the outcome variable, the dependent variable? Belief in God or religious belief. Yeah. Okay, great. So it's a bit confusing because they mentioned the outcome variable first. So it's good practice always, before you answer a more complex question, make sure you've understood what's the X variable, what's the Y variable. Sometimes if there's no manipulation, if they're both measured, it's kind of arbitrary. But when there's a manipulation, the X variable is the manipulated variable. The Y variable is always measured. Okay. So what are some strong or weak aspects of this research from what you can tell here? Yeah.
Sample size is pretty small.
Yeah, the sample size is very small by today's standards. So 26 in one condition, 31 in another. Back then, that was considered a medium sample size, but now we would say it's very small. Yeah.
Not very representative.
Yeah, the sample's not representative, it's college students.
Maybe not knowing who Rodin was or who Rodin was
Yeah.
or who, like, what does it, the thinker represents.
Yeah, so I would say just common sense suggests that a photo of the thinker might not be a very valid manipulation, so it might have flat construct validity if what you're trying to find is analytic thinking. Because if you're not familiar with the statue, or you just don't look at it closely, or you just don't associate, you know, someone sitting like this with analytic thinking, it's not good, that manipulation is not gonna have the effect, it's not manipulating analytic thinking necessarily, right? So I would question the construct validity, so I should have said, the first thing sample size would relate to statistical validity, the second critique that the sample is not representative would relate to external validity, this one I would say would relate most to construct validity.
Did they test for religious beliefs before they did the test?
So the question is, did they test for religious belief before they did the manipulation? They don't say that they did. That's not really a problem here because the X variable is manipulated. And presumably people are randomly assigned. I think they say people are randomly assigned to one of the images. So any pre-existing differences in religious belief should even out. But the small sample size actually means that that's less likely. So that happens if with a big enough sample size, pre-existing differences are washed out when you randomly assign people to condition. We can generally assume that that is true unless they didn't randomly assign people, or the details of how they supposedly randomly assign people. If there's something non-random in there, then we start to worry about pre-existing differences.
How were they recruited? Like,
How
was
was
it,
it recruited?
was it like an, if you like group of religious?
Yeah.
I don't know.
So like
some
how the study was
advertised.
advertised. Yeah, so what university were participants from and how was the study advertised? If it was advertised as a study of religious belief, you might get a selection effect of who enters the study. So those would be external validity.
What year?
What year was the study done? Do you think that might affect? So that would also be a kind of external validity about effects of the particular time period.
Is the control really a control? Like, could there be biases in the control
Yeah.
mode?
So could there be, I would call that a confound in the manipulation. So if the experimental condition, the thinker picture artwork versus the control condition weren't matched on everything that could potentially affect the DV, then there could be a confound in manipulation that's both a construct validity concern, and the manipulation is not valid, and it's an internal validity concern, because if there's a confound, then it's no longer what they think is causing the effect, it could be something else that is varying in the different conditions. Anything else? Okay, so there's one other big one I would say that I don't expect you guys to have figured out by now, but it's a good thing to know going forward. The p-value is quite high, 0.029, so it's 0.03 basically. That's quite a high p-value. And so one of the things that suggests to me is that there could have been p-hacking. So I didn't explain this logic last week. It's a bit complicated, so I won't go through it in detail. If you're interested, I can talk about this all day, so feel free to come talk to me. But especially, so a higher p-value, the closer it is to 0.05 rather than 0, the more skeptical I'm gonna be, the weaker the evidence in some way. So technically, we shouldn't be interpreting the p-value as strength of evidence. I'm oversimplifying a little bit, but practically speaking, you can think of it that way, that the more close to the p-value is to 0.05, the less strong the effect, so that's always true, everything else being equal. And the more likely it is to have been influenced by inadvertent p-hacking. So I'm not saying the authors sat there and were like, we're gonna p-hack this to, just below 0.05. But if there's unconscious, biases, motivated reasoning coming in, introducing flexibility into the way they analyze the data. So it's a case that when you p-hack, when you analyze the data multiple different ways until you get a significant result, even if you're not aware that's what you're doing at all, and most of the time we're not aware that's what we're doing. On average, it will lead to a higher p-value. Then when you do it right, when you do a study well, you design your research well, etc., and you run one statistical test, you get one p-value. If we map out what those p-values look like when there really is an effect, they're often very close to 0. Half the time or more, they're between, half the time or more that they're significant, they're between 0 and 0.01. So p-values between 0.01 and 0.05 should be more rare than p-values less than 0.01. Here we just have one, they didn't do multiple studies, so we can't see the pattern, but one high p-value still, for me, would increase my skepticism. It's controversial, but mathematically it's pretty sound reasoning. One step that authors could take to make people like me less skeptical is to pre-register their plan. So if they said, we're gonna collect this many people, we're gonna run exactly this statistical test, that's all we're gonna do, they time stamped that plan, they registered, pre-registered their plan. And then they did that, then even if they got a high p-value, I would be less skeptical because I'm like, well, that's a high p-value that you would get if you p-hacked, but you gave me enough information that I don't see how you could have p-hacked. You followed your plan pretty much exactly. In this case, there was no pre-registration, partly because the study was done well before that was popular. Any questions about that? So interestingly, for this study, the authors of the study, after the replication came out, said, yeah, no, we don't believe our study anymore either, which happens sometimes, and I think it's quite honorable when the evidence is quite strong. Okay, should we do one or two more? So I think we said no last time. All right. Hand washing reduces how strongly people feel the need to justify a choice they made a few minutes before. I think we already saw this one as well, but let's look at the details. So it's kind of hard to tell what they did from this description. So one thing that's important is they made a choice first, and I think we can get that from the headline. So they need to justify a choice. So they had to make some kind of choice that had some, I think, potentially moral aspect to it. And so the idea is that if you made a choice that was maybe less moral or more selfish, something like that, how much do you need to feel the need to justify it? So everybody made some choice. Maybe they even made it so that basically everybody made a questionable moral choice. I don't know how they designed that part to do that, but that sounds like that's what they did. Then the manipulated variable was whether or not people had the opportunity to wash their hands versus just examining the soap, it sounds like. It's really hard to tell what they did. But basically the manipulation was washing hands, or no, maybe the manipulation was just examining the soap. No, for those who wash. Okay, so you either just examined the soap, that was a control condition, or you washed your hands, that was the experimental condition. And so they predicted that washing your hands would reduce how much you feel the need to justify your choice. Maybe the choice wasn't even moral, I don't know. So hand washing significantly reduced. So hand washing is a manipulated variable, with the experimental condition being yes, you wash your hands, the control condition being no, you just looked at the soap. Reduce the need to justify one's choice, so that's the dependent variable. And they have a mechanism about how they think it happened. But this is the critical result, and the sample size is there. So probably many of the same criticisms we had for the last study would apply here, right? We don't know if they're college students, I would guess they are. So almost all of the same, right? Small sample. I would even call this a high p-value, but I'm pretty radical. Most people would call this an okay p-value. For me, if it's above 0.01, I start being skeptical, and then it depends on all the other factors. So if it's above 0.01 and there's a small sample size and it's kind of a hard to believe effect in the first place, then my skepticism goes up. But the rule I would like you to remember is just the higher the p-value up to 0.05, the more skeptical in general you should be. But pre-registration, a good pre-registration, helps soften my skepticism there. But even the authors themselves should be like, we didn't get a very clear result if the p-value is like 0.04 or something like that. Even with the pre-registration, like if I was a researcher and I got a p-value of 0.04, I would want to do the study again if it's easy to do and make sure that wasn't a fluke. Because something close to 0.05 could be a fluke in either direction. Okay, any questions about this study or how we might critique it? Let's see if the next one is different, because these two were quite similar. I don't remember if we saw this one last time. Maybe not. So students can spend 10 minutes immediately before a high pressure math test, writing down how they feel about the test, improve their performance relative to those who just sit quietly. So what's the manipulated variable here? Yeah, if they wrote about how they feel, or if they just sat quietly. So the variable would maybe be whether, I think it's called expressive writing or not. What's the dependent variable?
Test scores.
Test scores, performance. Yeah. Okay, so let's look at details about the paper. I don't think we had this one last time, so I don't know how we would vote. Oh, actually, they didn't do better on test scores. They were just more accurate Oh, I see, not, they weren't faster, they were more accurate, so they did do better on the test, but not, that they weren't fast. So in this case, they did have a pre-test and a post-test, so they did have everyone take the math test before the manipulation and after, even though again, when you manipulate a variable, that's less important, because you assume that the differences between groups wash out. On the other hand, they had sample size of 20, so something like 10 people per group. So the pre-test might be pretty important there, where random assignment isn't necessarily going to create equal groups with such a small sample. Yeah, so what do you all think of this one?
I think like with the expressive writing, it says they take several weeks or months to have an effect on decreasing rumination in depression, but they're only doing it for 10 minutes. And also it's not related to rumination or depression. It's related to test.
Yeah, so great, this is really good. So you point out the gap between the theory and what was actually done, and two important gaps. Yeah, so the intervention was much more light touch than what the theory says should work. And the outcome was pretty different than what the theory says that expressive writing is good for. Yeah, I don't know where I would put those. It could be construct validity, they could be external validity, like going from an artificial lab thing to real world, more broader implications, but also just common sense, right? Like writing for 10 minutes, that would be surprising if that had a big effect on performance, but maybe it does. Yeah.
I just think the control group, if they're testing for rumination and you're getting them to sit there for 10 minutes, then might as well just be ruminating anyway.
Yeah, so if the control group is just sitting there for 10 minutes, it might be that that's bad for you, not that expressive writing is good for you. Is that what you're saying? Yeah. Yeah, so maybe they wanted a more active control that was more, had the same, you want to keep everything between the control and terminal condition the same, except for the conceptual variable you're manipulating. So if what you care about is expressive writing particularly, you don't want the control group ruminating. You want them to be as occupied as the experimental group, just not in expressive writing. So have them do Sudoku, I don't know, something like that. Yeah.
It's kind of weird that they also include an incentive. Because it like kind of like
I missed that part, but I'm not sure. Yeah, why would you think it would matter? So
Just
could it
because it could-
interact with?
well, I don't know, maybe it would have an effect on who those which kids were.
Yeah. I would say the fact that you mean about the high stakes, is that the incentive?
Because monetary.
Modular, yeah. So I think my guess is they were trying to make it more realistic. So like a test that has a consequence for you. So by giving a monetary reward, they were trying to make it closer to the real world situation where your marks would be affected and that would have some consequence for you. But you could argue that limits generalizability, or you could argue that that's not a good way to mimic the real world. That monetary incentive doesn't make it more similar to real world context. Yeah.
I feel like just going back to what you said about ruminating, I feel like that's actually good for them because you were saying like they should be preoccupied, but the fact is like when you, I don't know, I just remember like when you're sitting in like an exam hall, you're like giving out the tests and everything. You're not paying for it.
Yeah. So maybe 10 minutes is a totally realistic time to be sitting before a test anyway. So they weren't introducing more opportunity to ruminate. They were just doing what would normally happen. Yeah, that's a good point. I would say maybe 10 minutes is a bit long, but yeah, I take your point. That a few minutes of sitting quietly is part of test taking. They could have had both groups sit quietly for a few minutes and then the experimental group do the expressive writing and the control group goes straight to take the exam. So that both groups would have had the normal period of rumination. So that wouldn't differ between conditions. Like I think if we say rumination is typical and normal and part of the environment, then both groups should have had it. And then on top of that, the experimental group should have the expressive writing. And then the question is, do you have the control group do something else? Do you have them just go straight to the exam? What do you do? Yeah, this shows how complex these critiques are, right? There's not one right answer. Yeah. So if you think that they shouldn't have had people sit quietly for 10 minutes because then it introduces the opportunity to ruminate, that would be a confound of manipulation, it'd be a threat to internal validity, would also be a threat to construct validity, the validity of the manipulation. They're not just manipulating expressive writing, they're also manipulating opportunity to ruminate. And at a minimum, the opportunity to ruminate should be the same between groups. So even if you think sitting quietly is part of the test taking experience, then it should have been part of the test taking experience for both groups. The only thing they should have differed on is the expressive writing.
But if the groups aren't able to, if the one that does expressive writing aren't able to ruminate, doesn't that indicate that it's the ruminating that causes the.
Yeah, it could be. So the problem, the reason it's called a confound is there are now two things that differ between the groups and we don't know which is causing the effect. So is it the expressive writing itself and specifically that intervention, or is it being distracted and not having the opportunity to ruminate? We don't know. So what they could have done is had three conditions. So the control condition they had that gives the opportunity to ruminate, a medium condition, I don't know if I would call it a control or a experimental, because it depends what your theory is about what the active ingredient is, but a middle condition where people do something else, so that you remove the opportunity to ruminate, that's your manipulation there, but you're not introducing expressive writing yet. And the third condition where you both remove the opportunity to ruminate, but you do so through expressive writing. So if that third condition is better than the second, then you have reason to think expressive writing is actively doing something, not just eliminating the opportunity to ruminate. Yeah, great. Okay, so overall, do you think this replicated or not? Remember, replicated is just like, even if most of these criticisms are true, it would still replicate, right? You would do the study with those problems again. So replication really just has to do with, do you think this was a fluke that it worked in this experiment? And if we did the experiment again, it wouldn't work. So it's not asking if it's valid, just if there's a real signal there in this particular way of doing the study. So who thinks it would replicate? Who thinks it wouldn't? Pretty even. I don't remember, and I'm really torn because the most relevant stuff for replication is statistical validity, right? So like the false positive is a statistical validity problem. And this, the most relevant things are the p-value and the sample size, and they pull in opposite directions. The sample size of 20 is so small that I don't really believe it. The p-value and the effect size is huge, a correlation of 0.79, that's insane. It's almost so big that I think it's wrong for some, like they made a typo or something. So I'm gonna be the tiebreaker and say no. Okay, I did not replicate. But to your point earlier, this doesn't mean the theory is wrong because it was actually a really bad test of the theory. So maybe like weeks or months of expressive writing does help reduce depression. This study really doesn't speak to that. Okay, so we'll stop there, go back to the PowerPoint. Okay. Okay, so one thing I want to emphasize is that what we just did, spending, 10 minutes or so evaluating a particular study with just a blurb, is actually not that common for people who do literature reviews. Many literature reviews do little or no quality evaluation. They put a lot of effort into finding the literature, and then they just treat it all as high quality. They assume that if it got published in a peer-reviewed journal, if it, whatever, it's been cited maybe a few times, things like that, therefore it's probably good quality. So even academic papers like meta-analyses, systematic reviews, research syntheses that themselves go through peer review and are published in good journals, often don't evaluate the quality or validity of individual studies. And this was the main theme of the readings for this week. If you didn't have a chance to read those two blog posts, I highly recommend that you do. I suggest that you do. It could be covered on the exam. And basically what those authors of those blog posts are saying is like, come on, like, look at the studies and ask yourself, does this look like a reasonable test of the research question that you're writing a lit review about? So we can do better. We should expect academics who do literature reviews to be better, but it's also a reason to not take even published literature reviews completely at face value. So let's say you have a research question, you're tasked with doing a summary of the literature on this, and you're lucky, there was a published systematic review very recently that's up to date. Maybe you could just take their conclusion. Well, I would go in and look at whether they say they scrutinize the quality of the studies and how they did so. And if they don't say either way, you could go and look at a few of the studies. And so what the authors of the blog post did is for some of the published meta-analyses that they were critiquing, they just looked at the biggest effects in the meta-analyses. So they found the studies that showed the biggest effect that were included in their literature review and just looked at those studies really carefully. And that's a good way, if there's going to be studies you shouldn't believe, is very often going to be the ones with the biggest effects, like that last one of a correlation of 0.79, that's kind of crazy. And when we look at it more closely, we see other reasons besides the effect size to be skeptical of it. Okay, so what is quality? Yeah.
Before we were saying that like in marketing or management, we shouldn't always rely on scientific evidence. I'm wondering what scientific evidence counts as, because if we say like, I don't know, if you go to the economy world, does that count as science? If you go into, you know what I'm trying
Yeah,
to
yeah.
get? Like, how do we
Yeah.
know what counts as scientific and what not?
Yeah, that's a very broad question. I'm actually doing a debate next week at the same time as this class, otherwise I would invite you all to come. But for a philosophy of science class, I'm debating is psychology a science? And it's a really, really complicated question. I mean, almost everybody who's a psychology researcher says yes. I'm arguing the no side. But you could ask the same thing about many social sciences and honestly, some life sciences as well. I would say, like, do things that are not super scientific. But ultimately, I think almost everybody within those disciplines would say they are sciences. And when I'm saying scientific studies, I'm including social sciences, economics, political science, psychology, communication, media studies, so many disciplines. Then there's like a whole set of disciplines that are kind of in between humanities and social sciences. So many of the disciplines with studies in their name, media studies might be one example, African American studies in the US or things like that. They're a combination of science and humanities. They're scholarship, they're knowledge, but not always just using science. So I guess what I'm calling scientific evidence here would be qualitative and quantitative designs that try to collect data and somehow follow some rules. You know, I don't believe in the scientific method, so I couldn't articulate exactly what counts as scientific. I think it's blurry, but yeah, I would say that those disciplines that consider themselves sciences, which is mostly the natural sciences, the life sciences, and the social sciences, I would include as scientific evidence here.
And then if there is no enough evidence there for what, like your specific project, then you go into looking into those realms of economics and social science.
Well, I would include economics and social sciences in that first as evidence.
Okay,
Yeah.
so
So I would say very often for the kinds of questions you all would be dealing with, the primary evidence base would be social sciences, economics, sociology, psychology, marketing and management departments, you know, people in those departments that have training and often in these other backgrounds. So that literature, those journals, scientific journals that publish in those areas would be the primary sources you would be consulting for the most part. And I'm saying, yeah, if the evidence there isn't super strong and relevant, make sure that you don't overweigh it. And even if it is super strong and relevant, there are other sources of evidence outside of science that are likely to be relevant. Of course, there are people who underweight or undervalue science. I'm just emphasizing the overweighting because I think that's more likely among those of us who, you know, value science. But of course, there's also another bias to watch out for is people who value science not at all, or blanket, kind of put a blanket discounting on science, even in the cases where there is really good scientific evidence. There's a debate this week as part of Science Week on Wednesday before the Matilda game, I think it's 6, that will be about science denialism and what scientists should do or think about science denialism. And I think that's going to be really interesting because I think it's so hard to, it's hard to define science. It's really hard to define science denialism. So there are, you know, arguments against vaccines or climate change that are relatively clearly bad faith arguments that ignore valid science, in my opinion. But there's also really good, thoughtful, nuanced debate about some scientific things, including some questions close to those. So I don't think there's much debate about whether vaccines are effective or whether climate change is happening, but I think there are valid questions on the edges of those issues and on other controversial issues where sometimes we are too quick to lump something as science denialism when it's actually a valid critique of the evidence, even if, so what's complicated and hangs people up is that often the conclusion might be true, but the evidence is bad. And in that case, I think that those of us who value science should be willing to say, that study was very poorly done. I still believe the conclusion for these other reasons, but I don't think that was a good study. Of course, on social media and stuff like that, you can't even try to have that level of nuance. It won't work, but we should still aim for that in our kind of more personal discussions and private discussions. Okay, so what do we mean when we say, I don't think this was a very good study, or I do think this was a very good study. So there's a few things we're going to talk about transparency, but we touched on this quite a bit last week. So I'll go through this part pretty quickly. We'll talk about the importance of evaluating the validity of the studies. We did obviously spend a lot of time last week on validity, but we're going to go more in depth here in the context of evaluating published work, and then we'll touch on calibration. So to me, those are the 3 kind of pillars, categories of things I look for. Obviously, the middle one is the most directly relevant to quality. It almost is quality in itself. But the other two are kind of supporting the validity of the study or our ability to assess the validity of the study. And I'm not talking here, I'm assuming that you've already evaluated the relevance of the study for your purposes. I'm just asking, should we believe the conclusion? Okay, so why transparency? And this is actually shockingly has been controversial in recent years in psychology, at least, and I think in many sciences. There was a period from about 2011 to 2016, 17, where the field of social psychology, at least, I think many of the fields, were having bitter fights and debates about whether transparency is a core value in science. So I think one side has won. I'm a little bit biased because I'm on that side, that yes, transparency is important. But what's interesting is that it's not a debate outside of like to scholars of science, philosophers of science, sociologists of science, etc. To them, it seems very obvious that, of course, transparency is a core value of science. And I feel like we've kind of lost our way in our practices. Part of the reason too is that it used to be almost impossible to be totally transparent. Before the web was what it is now, it wouldn't have been very easy for me to share my data. My data would have existed on like cards that you stick into a machine. My protocol would have been paper and pencil, etc. So it's much easier now to share your data, share your materials, etc. Now that there's the web and it's as easy to access. Yeah.
What's the argument against transparency?
So one argument against transparency is that it's just bureaucracy. You're just asking researchers to do more work. We already have ethics approval. We already have all this oversight, and then it's going to stifle the ability of researchers to be innovative and creative and so on. Another argument is that we should just trust each other, that asking people to be transparent creates a culture of mistrust and suspicion, and we don't want that. It's toxic and so on. Another argument against transparency, and I literally heard this as an argument against transparency, which to me is an argument for, but I was in a meeting where we were talking about what the guidelines should be for a particular field or journal. And one of the researchers said, well, we can't ask people to be transparent because being transparent is giving your critics ammunition. And I thought, yeah, exactly. But to that person, that was the reason why we shouldn't expect people to be transparent. And it's true that, of course, no one's going to, not no one, but many people are not going to want to be transparent. They're not going to be like, here you go, tear me apart. But it's all the more reason that it should be a guideline and a minimum requirement in those cases. But there are cases like climate change denialism where transparency is used by bad faith actors against, scientific consensus and societal improvement and so on, progress. So I do think we have to be realistic about how that transparency could be used as ammunition in an unfair way against people. And this is where the debate comes in. Is the solution then to not be transparent? In many ways, that just gives them even more ammunition, right? If someone wants to paint you as not a serious researcher, shouldn't believe their results, not being transparent, you're doing a job for them, in my opinion. I think we need to be transparent, but we also have to have some norms around so there's the norm that like if I publish my study and I publish my data, someone finds an error and it emails me, I should take that seriously and correct it if they're right and so on. There are people who basically troll researchers by saying they found errors and so on, and suck up all those researchers' time for political reasons. I have friends who do research on controversial topics who are in this position. And so then their struggle is like, when do I have to take a critic seriously? If I just ignore all my critics, that's not good. But if I stop what I'm doing to address a potential criticism every time one comes in, I would never get any work done, which is arguably the point of some of those critics. So I do think that's a complicated problem. I don't think the solution is to not be transparent at all. I think that, again, like just using common sense and reasoning, that if there are reasons to think someone is acting in bad faith, you have less obligation to take them seriously, maybe no obligation, etc. But I admit that it's tricky. So those are some of the arguments. I think also there's just inertia, right? We didn't used to be transparent because there wasn't the web, or it was much more restricted. Now that space is so cheap on the web, people aren't used to it, and so they don't want to do it, and then they rationalize not wanting to do it. We don't want to learn new things. I mean, I'm old enough now that it's hard for me to learn new things, or I don't know, I'm lazy. So there are plenty of things that I'm sympathetic to the feeling of like, I don't want to have to do this, but I wouldn't go as far as to argue that I shouldn't have to do it. I'm annoyed and will complain about doing it, but.
Do you think it's also could be that research, because like when critique people that are criticizing companies' works, it's kind of coming from not necessarily a moral standpoint, but like, it feels like a moral thing, like, oh, you're a bad researcher, you did something that's dishonest.
Yeah.
So then you're a bad person.
So there's a lot of debate in psychology right now about, what kind of criticism is professional and polite and so on versus what is personal attack, what's going too far. So that's part of what's going on with the fraud case that I mentioned with Francesca Gino, where she's suing the bloggers, actually the same bloggers that are looking for this week, for defamation because she thinks that their attacks went too far, were too personal and so on. And in her case, she's arguing that they were motivated by sexism. Many of us look at the content of those blogs, again, not the same blog posts I assigned to the same bloggers, and don't see any evidence of that. To many of us, it looks completely within the professional realm, but that's such a hard subjective judgment call. One activity I do sometimes in my PhD seminars is I take examples of ad hominem attacks. So ad hominem means like you're attacking the person instead of their ideas. So some researchers went through a bunch of peer reviews and selected out some ad hominem attacks. So to the researchers who wrote this paper, they thought these were examples of cases where a reviewer went too far and was unprofessional. And I'll put them on the screen and we'll vote as a group about whether these statements went too far or not. And so it's very easy to pick statements where we get pretty much a 50-50 split. So like this paper is wrong and the researchers are incompetent. Okay, I think that goes too far. What about just this paper is wrong? If you don't say, so people think that's too harsh. I think no, a reviewer should absolutely be able to say, in my opinion, this paper is wrong. So there's a lot of stuff about like, what's appropriate, what's fair. And so if you think that most criticism goes too far as unprofessional, I guess you could justify not being transparent because you think that you would be opening yourself up to unprofessional, toxic behavior. Okay, but the arguments for transparency, I think that they're almost so straightforward that they don't need to be stated, but here's one pretty eloquent way of putting it. So these researchers are from political science, said that the credibility of scientific claims comes in part from the fact that their meaning is at a minimum available for other scholars to rigorously evaluate. Such open access to the origins of others' claims is the hallmark of scientific ways of knowing. So when social scientists fail to document their assumptions, their decisions, their actions, it limits others' ability to understand the meaning of scientists' claims. So basically they're just saying it just is fundamental to doing science, right? We learn in grade school that you show your work and when you're doing science. And so it seems a bit weird to ask. And I often have this experience when I talk to people outside of academia and outside of science. In the early days, in the 2010s, when we were having these fights in psychology, people would say like, wait, people are arguing against transparency? That just seems so obvious that scientists should be transparent. It's also the motto of the oldest still existing scientific society, the Royal Society of Science in the UK. Their motto is nullius in verba, or take no one's word. So this idea of distrust is fundamental and really old in scientific thinking. Okay, so actually I think a lot of the same people who argue against transparency in concrete ways, they say we shouldn't have to share data, we shouldn't have to do that, they will still proclaim publicly that the reason science is trustworthy is that we show our work, that we question each other, and so on. So I think almost no one disagrees on these fundamental principles. We disagree on how to translate that into behavior. What should we be transparent about? So let me talk through a little bit this. I'm going to go a little bit more in depth on key hacking. We talked about it a little bit last week, but why transparency is so important in the context of researchers being human, being influenced by motivated reasoning, and so on. Okay, so what I'm going to argue happens is that when we do research, we often get results that should look like this. They should be quite messy, not always supporting what we want, etc. But what ends up published very often looks like this. And that's not because the researchers necessarily are intentionally doing that. It's a combination of many factors. So if we had an unbiased view of what results look like before any bias comes into play, we would occasionally see a really beautiful result, but the vast majority of results would be messy. Some would be going against our theory. Some would just be, who knows, there's a lot going on here, we can't tell, it's not conclusive. Or some would be mostly supportive of our theory, but not totally clean. Okay, so how do we get from a set of findings that should look messy and complicated to a set of findings that's mostly clean? Well, there's a few things. So one is that we can turn some messy results into neat looking results by doing what's known as harking, which stands for hypothesizing after results are known. So the HARK stands for hypothesizing after the results are known, which just means I do a study, either I had no expectation about what I would find or I expected a particular finding, but then I get a different finding. I don't get the one I expected, or I get one I didn't expect. But it's interesting enough that I could tell a good story around it, and I write up my paper as if I predicted that. So I kind of create the hypothesis after I've seen the result and I write my data that way. So this is very common. And it's, it was actually literally in instructions that were given in a paper written by Daryl Bem called How to Write a Research Article in Psychology or something like that. That has a lot of really good advice, but one of the things he says in there is to write your paper. Now that you know the results, write the most interesting, compelling paper you can from the introduction already. Write your introduction to set up that interesting result, even if you didn't expect it. I used to teach PhD students to do that. Everybody did it. People still do it quite a bit. Then the next one is p-hacking. So this is what we talked about last time where, I can't remember if I have slides specifically on this, but where you, again, without necessarily being aware that you're doing it, you reanalyze your data in different ways. You think of reasons to exclude specific measures or specific participants or things like that. And you're not aware of being motivated by trying to get a particular result, but that's actually what's driving your decisions or having a strong influence in your decisions, that you're less critical of a result if it's what you wanted and significant. But if it's not, if it's either not significant or in the wrong direction or something like that, you might be more likely to go back and think about how the analysis might have been wrong, what analysis should do differently, and so on. So that allows us to turn many of these messier findings into tidier, more perfect papers. But for the ones, you know, there's also cases where maybe we can't or we don't want to turn them into beautiful, tidy papers. We don't manage to convince ourselves or so for whatever reason. But then what happens is that researchers might just not publish those. So that's called file drawing. So those findings just don't appear in the literature. So I ran the study, I didn't get the result I wanted. Maybe I tried to be hacked, maybe I didn't, I don't know. But I decided to just not publish the study at all. And maybe I think of a good reason, right? I justify it to myself that there was a reason why I did that study wrong, I need to redo it. But even if I want to publish it, there's another thing that happens. So let's say I ran my study, I didn't get the result I wanted, but I decided I should publish it anyway without p-hacking, present the results in their messiness. But then journals will tell me they don't want it, and that's known as publication bias. So that's journals rejecting papers that don't look neat enough or tidy enough or significant or yeah, so it's usually biased in the direction of statistical significance and interestingness and novelty, flashiness, stuff like that. So very few findings make it all the way through, avoid all of these ways of kind of being massaged or filtered and make it through as messy findings. But things are changing a bit. There's meta research evaluating the literature suggesting that we are getting closer to a more representative literature by kind of helping to identify and prevent some of these things. Okay. So hardening is hypothesizing after the results are known. It's changing your hypothesis and but saying it is planned. P-hacking is analyzing your data different ways and only reporting the significant results. And also either explicitly saying it was planned or implying it was planned, not explicitly acknowledging that actually we changed some things after we saw the results. Okay. Any questions about that? Okay. So what ends up happening is that through these things, hardening, p-hacking, file drawing, publication bias, again, very often unintentional, very often not conscious, not deliberate, except the publication bias is pretty conscious and deliberate on the part of journals and editors. They will often be explicit, like drop study 3 because it didn't work and your paper is tidier without it. But sometimes journal editors will explicitly tell you to file draw a specific study in the paper. But as I said, things are changing. You know, it's kind of a glass half empty, glass half full in terms of how much and how fast they're changing, but they're definitely going in the right direction. There are more and more journals that are aware of these things and are trying to combat at least publication bias, which they have a lot of control over, but also trying to tell their researchers, tell their authors, we don't want the neat, tidy picture. In fact, we're going to be more skeptical if you send us something that is like too good to be true. So one journal that's a great example because it's quite prestigious. And so usually the journals that change faster on this stuff are the less prestigious journals. They're more willing to publish messy stuff. But there are a few very prestigious journals that are changing, or at least claim they're changing. It'll be interesting to see how much the literature changes. But Nature Human Behavior, again, is a quite prestigious journal. And they have a couple of editorials. One is called Tell It Like It Is. So this is the editors talking to researchers who might submit. They say, look, every research paper tells a story, but the pressure to provide clean narratives is harmful. Hence, so they say science is messy and the results of research rarely conform fully to plan or expectation. Clean narratives are an artifact of inappropriate pressures and the culture they have generated. We strongly support authors in their efforts to be transparent about what they did and what they found, and we commit to publishing work that is robust, transparent, and appropriately presented, even if it does not yield clean narratives. So it's good that they're asking for that they're stating their commitment to doing that, and it'll be interesting to see how the literature changes in their journal based on that. Okay. Okay, another kind of transparency is pre-registration. So we talked about this last week. This is where you write down a plan ahead of time as detailed as possible, but even if you don't have all the details, at least then you're being transparent about the fact that you didn't make these decisions ahead of time. So if you know it, you say how many people you're gonna measure, what you're gonna measure. If you have manipulation, what are the conditions, what's your analysis plan, and what's your key hypothesis sets? What is the one critical p-value that you will base your conclusion mostly on? You write it down and timestamp it, so you can do that. There's different registries where you can timestamp your pre-registration even before you're ready to make it public. Then you collect and analyze your data. And when you are ready to share your paper, you can make your plan public at that point. So once I'm saying, hey, this is what I did, it was all planned, believe me, now I can make public my registration. You can go and see that it really was all planned or not. Okay. This is the Daryl Bem paper about how to write a research article that I mentioned before. So this is what it says about how you should write the article. This is the part about harking. So he says, there are two possible articles you can write: the article you plan to write when you design your study, or the article that makes the most sense now that you have seen the results. They are rarely the same, and the correct answer is okay. So he's explicitly telling people, don't write the introduction and the article you're planning to write ahead of time, whatever reason you did the study, whatever you expected to find. You don't need to bother readers with that. The conventional view of the research process is that we first derive a set of hypotheses from a theory, design and conduct a study to test those hypotheses, analyze the data to see if they were confirmed or disconfirmed, and then chronicle the sequence of events in the journal article. This is what people are taught that science is. But this is not how our enterprise actually proceeds. Psychology is more exciting than that, and the best journal articles are informed by the actual empirical findings from the opening sentence. Before writing your article, then, you need to analyze your data. And then he says, when you're analyzing your data, think of your data set as a jewel. Your task is to cut and polish it, to select the facets to highlight, and to craft the best setting for it. Many experienced authors write the results section first. So you find your most exciting result, you write your results section, then you write the whole paper around that exciting result. So it's important to know that this is what researchers have been trained to do up until very recently. And I would argue still probably many, many researchers, at least in psychology, but I don't think psychology is unique, are taught explicitly to do this. And I actually commend them for saying the quiet part out loud, right? Most of us train each other, train our students to do this, but don't actually admit that that's what's happening, and we present to the public a very different picture that everything, we don't make it clear that these things were not actually planned, that this was after the fact. So I would say now it would be hard to find a psychologist who would admit to doing this or to training students to do this, and I've certainly changed my practice. I don't train students to do this anymore. But I think it's still a good assumption that when you're seeing a paper, they might be operating in this world, not the scientific practices that we kind of teach and preach publicly, but this more common norm of it's okay to do this. So I would not take very seriously if an author says that this was planned or predicted, or if even they tell a story as if their exciting finding was what they believed all along, what they were trying to find all along. And this is why pre-registration becomes so important, right? In a culture where we know this has been acceptable for a really long time, we can't really just take an author's word for what they plan. So pre-registration is a way to kind of show, you don't have to just take my word for it. I timestamped my plan ahead of time. You can see what I expected to find. Okay. Another way to help block these biases from coming in and becoming ourselves even stronger than pre-registration is something called registered reports. I can't remember if we talked about this last time, but I'll go over it quickly. So a registered report is a new kind of journal article that has only existed for a few years, and that not all journals adopt, and so they're still quite rare in the literature. But what happens here is that the authors will write up their introduction and their planned method section and their planned analyses. So like kind of a first draft of introduction, method, and results without any actual results. They haven't ran the study yet. They're giving the justification for the study. They're describing basically what they would put in a pre-registration. What are we going to do? How are we going to do it? How are we going to analyze it? So they develop the idea, they design the study, they write up the intro, the proposed methods and the proposed analyses, and they submit it to a journal, and it goes to what's called stage 1 peer review. So the stage 1 manuscript, which is before any data exists yet, gets sent out for peer review, and if the editor decides to accept it, they might request some revisions. The nice thing is actually you can request revisions not just to how the data are analyzed, but you can request revisions to how the data are going to be collected. You can say that's not a big enough sample size, or you have this selection effect of who's going to participate in your study, or your manipulation has a confound, or whatever. You can fix those problems before the study is run. But if the editor ends up giving an acceptance to the paper, it's called an in-principle acceptance, or IPA, then they send that to the authors and say, go ahead and do the study, but you have to do what you said you were going to do. And if you do, we will accept the paper regardless of how the results come out. So both sides are making a commitment. The authors are making a commitment to doing what they planned, what was agreed with the reviewers and editor. And the editor and the journal are committing to publishing the paper as long as that is what happened. So the authors go off and collect data, they write the report. There's still a stage 2 peer review. It can't be rejected here, except in extreme cases where the authors didn't do what they said, or their conclusions don't match the results at all. So they did what they said, they found X, and then they say, oh, look, we found Y. Right? In that case, you might reject it. But there's very few reasons why a journal is allowed to reject at this stage. So it's just to make sure that the authors actually did what they said. So what's interesting about this is that if you think about this, all these different things that can go wrong. There we go. So arcing becomes impossible because your introduction is already written, you can't change it. P-hacking becomes much more difficult because you lay out exactly how you're going to collect and analyze the data, and then you have to follow that plan. File drawing becomes, well, I guess the authors could just never submit the stage 2 manuscript if they don't like the results they get. But more and more it's becoming harder. Journals are now publishing the stage 1 report. If that happens, the stage 2 report never comes in, the journal will publish, hey, these authors said they were going to do this study. And then publication bias should be mostly eliminated because journals and editors can't choose to reject it after they see the results. So it mostly takes care of a lot of these biases. So then the question is, what happens if we manage to close off a lot of these sources of bias? What does the literature look like? So before registered reports, or in the traditional literature, which is still the majority, again, registered reports are still rare, but in traditional articles, it's well known, there's been a lot of meta research showing that something like 95% of psychology articles find a significant result consistent with their theory. So in the traditional literature, the percentage of papers where the hypothesis is not supported is about 5% in psychology. So 5% here is where in the traditional literature, the researchers did not find what they expect. In other sciences, it's a little bit higher, like maybe up to 10%, 20%, but many sciences, it's extremely rare in traditional in scientific articles for authors to not find what they expected. So then these researchers and some other researchers also looked at registered reports. So there's not very many, there's 100 to 200 at the time that this research was done. And they said among registered reports, how often is the key result not supporting the theory? And it's 55%. This is for novel studies, so when the researchers are doing a new study, not a replication, it's 55% are not significant or in the opposite direction, but usually just not significant. They also just looked at just the registered reports that were replication studies, and they're 66% of the time they don't work, which is pretty similar to the results of other replication projects that tried to estimate the replicability of studies. So this is biomedicine and psychology, 296 hypotheses across 113 studies. So this was a few years ago now. There would be several hundred more registered now, so it'd be interesting to update those and see. Now you could think, well, okay, maybe these studies that the authors who choose to do registered reports maybe are studying riskier hypotheses. Maybe the null hypothesis just is true more often in those studies than in these studies. That's possible. So then some of this extra non-significance would be accounted for by that. But I think what's more likely is that these are very similar hypotheses being tested in this literature to this literature. I mean, the case replication studies, we know they're the same, because they're replications of papers in this literature. But when we close all these doors to bias, a lot of significant findings turn back into non-significant findings. So that's both kind of scary in terms of thinking about probably a bunch of these are false positives or not true findings. But it's also somewhat hopeful that maybe registered reports are a good solution to closing the door to these biases. So if you're doing a literature review and you find registered reports on that topic, maybe trust those more than the ones that are not registered reports. Probably you won't find any registered reports because they're, again, quite rare, but that's changing pretty quickly, so hopefully that will change.
Is there a problem also, I mean, I don't wanna go over the line maybe, but if we only publish results that are not significant, people are gonna stop reading these journals?
So the concern, one of the reasons journals defend the practice of publication bias, of rejecting papers or studies that are not significant or not interesting, is that they're like, well, we want, our job is to publish interesting things. If we published a lot of null results, people would stop reading our journals. I think there's several interesting things to say about that. One is that it's an empirical question, and I'm not sure it's true. So some of the replication studies that have found null results have had a really big impact. They get cited a lot, they get discussed in the media. They don't actually have an impact on the original study getting cited and getting attention. So the original study continues to take off, and the replication study that found different conflicting results and is often more rigorous also gets quite a bit of attention. But maybe that's because replication studies are a new thing now, but when the fad passes, maybe they will be boring, no one will care about them. But then I think the question is, okay, so where should the more complete scientific literature go? It needs to go somewhere. But, if we want to make scientific progress, we need all of the literature out there. Otherwise, people doing meta-analyses and literature reviews aren't going to be able to find, an accurate, set of studies. So, and the problem with all the answers to that is like, oh, maybe we can make specialized journals for null results, or maybe we just preprint them and leave them there. Those don't help your career. So if you publish in a specialized journal that is for boring studies, or if you just preprint your work and you don't publish in a journal, you will stop being an academic. You will lose your job. You won't get grants, etc. So that is not a really good solution. And I actually think we should question that first premise that journals' job is to be read a lot. I'm not sure. I think scientific journals' job is mainly to accumulate and share good studies, whether they are interesting or not, to a point. So, like, for example, as a journal editor, my policy is that we don't evaluate how important or how interesting or exciting the results are. We make our decisions independent of that. But we reserve the right in extreme cases to say this study really didn't need to be done. So, for example, in intro psych, you probably learned about the Stroop effect, where it's easier to identify the color in which a word is printed if the meaning of the word is the same color as that color. That's been documented a million times. You can get it in every demonstration, in every class, etc. If someone submitted a paper to my journal saying, we ran a study to test the hypothesis of the Stroop effect, we confirmed it, here you go, I would say, yeah, you really didn't need to do that study, and I would reserve the right to reject it. If there was something new or interesting about it, so this is like the kind of logic that I'm generally against, but in that case I would apply. So it's a tough question of like, where should journals draw that line? So I think it's fair to reject some things on the basis of the study should never have been done, not because it's bad quality, it's just not interesting enough or important enough. I think journals go way too far in that direction, and partly based on assumptions about what's going to be interesting to people, but also based on this idea that that's their main or primary purpose is to be interesting. And it's because that's what they're incentivized to do. Journals are ranked based on how many citations their papers get, their journal impact factor. And so their job, they see their job as boosting their impact factor, which means publishing the most exciting, flashy results. But who decided that was their job? Who decided that's how journals should be ranked? So there's now a competing ranking of journals called the top factor. Top stands for transparency and openness promotion factor, that ranks journals on their the transparency of the articles they publish and their policies around transparency. So it's trying to put pressure and incentive on journals to care about other things than just publishing really flashy papers. But yes, your point is exactly right. The journals think that they're justified in rejecting boring papers. And it is a tough problem to solve. Okay. So maybe registered reports would help kind of bring the literature back. I don't want to exaggerate this too much. I think that in principle, registered reports should serve this function of kind of de-biasing the literature. In practice, it's going to depend on how good the editors and reviewers are who monitor the registered reports and hold the authors to the stage one and hold themselves to the policy of not rejecting based on results and so on. And I think as registered reports become more popular, more editors do it, more journals do it, the quality control is going to go down. So it might not be quite as effective, but still a good development, I think. Okay. So transparency means sharing enough details of your procedures and your materials and your data that people could run the study from scratch. They would know everything you did and be able to mimic your procedure, reuse your materials, and or researchers could download your data and reanalyze it and make sure they can get the same results. The first one is called replicability. The second one is reproduction or reproducibility. Also making sure all relevant studies and all relevant results are reported, so we don't hide some studies or hide, again, sounds too active, but we don't decide not to include some studies or some analyses because they didn't come out the way we wanted. And any unplanned analyses and results are honestly reported, clearly marked. We don't say that we did plan them or that we expected those results. So pre-registration lets readers see what was planned and what wasn't. Registered reports go further than pre-registration and provide some protection against p-hacking, harking, and also publication bias. Those are the main things I mean when I talk about transparency, but there's a few other kinds of transparency that we're not as good at in psychology. One is declaring conflicts of interest. So this is very common in medicine, but not very common in psychology. And there's still debate about what counts as a conflict of interest. So it's considered completely fine in psychology to not declare if you're making a lot of money off of a popular book or giving talks to companies based on your findings. That's not considered a conflict of interest in psychology, even if it can be a bigger source of income than your salary as a researcher. We also don't consider it a conflict of interest if an editor publishes in their own journal. That's almost never declared as a conflict of interest. We're about to publish a paper showing that this happens quite a bit and arguing that it should at a minimum be declared as a conflict of interest, maybe even banned to some degree or like limited somewhat. But those in psychology, it's completely common for people to have these conflicts and not disclose them. Also, what each author contributed should be disclosed, and there's a movement towards doing that more. It's called contributorship. So saying what contributions, who did the writing, who did the data analysis, who did the whatever. The broad cases are showing why that would be useful, right? All the authors immediately say, I'm not the one who did the analysis, or I didn't handle the data. So it would be good to disclose that, both to give credit to the people who did the work and to also assign responsibility.
That's hard because, like, in most cases, when you work on a paper, everyone works on it.
Everything.
It's not just like.
Yeah, so in a typical case of like 3 or 4 researchers doing research together, then everyone would probably have a hand in everything, but not always. So for example, I've now gotten so out of touch with statistics that I don't analyze the data myself. I will look and interpret the analyses with the authors, and also data collection is often outsourced to a specific person. Also, it could be important to contribute the funding for the study. That's often just one person. So there are some roles that are more unique, and also there are more and more bigger team studies. So some kinds of studies where you have to have a team of 20 or 30 or more collaborators, and there it's very common for people to have this one role. Like their responsibility was to check the reproducibility of the code. Maybe people like bring on a co-author just to do that. And actually, under the strict authorship guidelines in psychology and medicine, that person would not be allowed to be a co-author. If you don't participate in the writing, technically you're not supposed to be a co-author. So part of the reason for the move to contributorship instead of authorship is that we should give credit to everyone who did a job, even if their job was quite technical or whatever. The other thing that happens that's bad is that often someone will get authorship just for providing the funding. And that violates the rules of authorship. And it's also ethically questionable that if you weren't involved in the intellectual work of the research, you shouldn't be a co-author. But maybe it is a recognition for providing the funding. So contributorship model would allow you to add the famous person with the grant and say all they did was get the grant and pay for the study. That's still something. So contributorship would help with many of these problems, and they're becoming more and more relevant the more there's big team science, which for many tough questions, you do need a really big team to tackle it. And then another kind of transparency that doesn't get talked about, but again is becoming slightly more common, still early days, but I think we're definitely moving in this direction, is that when a paper is published, the peer review history of that paper can be published too. So all the comments of the peer reviewers and the editors and the back and forth with the authors during peer review, all of that history could be published as well. Now that the web, now that there's so much space, it's not hard. When it was like had to be printed in a journal, I understand why it wasn't published. But now I think there's no good reason not to publish that, to show, here's the process it went through, here are the criticisms that were brought up, here's how the author responded. To allow readers to see it. Was this a rigorous process? Were there good reviewers who were thorough, etc.? Or did they get an easy pass? Maybe the authors are famous and everyone was like, great job, and that's all. So it's important to show that. It doesn't necessarily mean revealing the identities of the reviewers. That's very controversial and I'm not necessarily for it. But you can still reveal the content of the review without revealing their identities. Okay. One more point before the break. So transparency is necessary for evaluating quality. So without transparency, you can't as easily evaluate quality, but it's not the same as quality. And it doesn't guarantee that a paper is high quality. So transparency doesn't guarantee credibility. It could improve credibility because through transparency, people point out more things. So in a registered report, you're transparent about what you're going to do and people can help you improve your design. Or even in a traditional paper, if I share my data at the time of peer review and I'm asking to publish it, the reviewers could go into my data and reanalyze it and say, oh, well, it doesn't work unless you do it exactly the way you did it, but probably the way you analyzed it multiple different ways and all the other ways you would have analyzed it, it didn't work. That kind of transparency allows for correction, which might make the eventual resulting paper much more credible. But the other possibilities of transparency just shows how bad the work is, right? So an author writes a really beautiful, neat paper with a beautiful design, beautiful narrative about how they expected everything. But then if they're transparent, they show their pre-registration, etc. You see that actually there's all kinds of errors in there. They're way overclaiming. They didn't do what they said they planned to do, etc. And so you just get all kinds of errors, and they're really, really big errors, really problematic. And so then that paper, or if it's happening at the field-wide level, so if a field becomes more transparent, if everybody becomes more transparent, there's no guarantee that we'll end up getting more credibility. It depends if we fix our errors that come up when we're transparent. So the difference here is, are we doing the right thing from the perspective of the design and methods that we use? Are we doing high quality research? Are we responding to criticism to improve our research, make it higher quality, and not continuing to make the same mistake over and over again? So one way I put it sometimes that transparency doesn't guarantee credibility. Transparency just means that we get the credibility we deserve. The transparency means that if we did good work, then it's evaluated as higher quality, and if we did bad work, it's evaluated as lower quality. Compared to a world where researchers aren't transparent, then it's much harder to tell what's the good work and what's the bad work. Andrew Gelman has a nice 2-page paper called Honesty and Transparency Are Not Enough, where he says basically that a researcher who values transparency, understands the value of transparency, but doesn't learn about the importance of quality, of doing things right, because it's considered the consequences of a researcher who eagerly accepts the message of ethical and practical values of sharing and openness, but does not learn about the importance of data quality. That researcher could then just be driving very carefully and very efficiently into a brick wall, conducting transparent experiment after transparent experiment, but continuing to produce and publish noise. Okay, so transparency is not enough, but it's a path towards potential path towards credibility because you're giving your critics ammunition. And if you survive that, if you're still looking strong after that, or maybe you make changes and improve on that, then you can earn much more credibility than you could without the transparency. You can also lose credibility by being transparent about the shoddiness of your research. Okay, let's take a break here and come back in 15-20 minutes.
Quick snap.
Alright, let's go ahead and get started again. I know we're still
I have
busy.
an honor my bag.
Yeah.
Oh, maybe only-
So sour.
Yeah, I'll wait till we're in.
I was surprised by these ones, because the past couple
Alright, let's go ahead and get started. If you haven't signed in, please make sure you sign in on the clipboard at the back of the classroom. Okay.
I've been sick.
So we've covered transparency. Now let's get into the harder and grittier stuff about how we assess the validity of the study itself. So obviously, some of this requires expertise in the exact area that the study was done in, and you might not have it. I don't always have expertise enough to evaluate validity of every piece of a research study, even in my own field. But there's a lot we can do even without that kind of expertise. So in the Data Colada blog post that I assigned for today, they talk about, it's in a footnote, but they talk about locally invalid studies. So this is really important because the idea is that the validity of a study or method depends on the aims of the research and how the results are being interpreted. So a study design or method could be valid for one conclusion, one claim, and invalid for another. So we talked about this a little bit at the beginning of last week, but that a method, a measure, a design isn't just valid or invalid. It's valid or invalid for a particular purpose. So something could be a bad measure of one construct and a good measure of another construct. So its construct validity depends on how that measure is being interpreted. Okay. So we're going to talk a little bit about how to evaluate validity, you really have to keep in mind the entire big picture of the research. You can't just zoom in on a method and evaluate its validity, right? You have to know what is it being used to test, how is it being interpreted, and all of that factors in. Okay, so when we're evaluating validity, there's a few things we can I'm going to just highlight some like kind of shortcuts or easy low-hanging fruit of things we can look for when evaluating validity. Like the kinds of things that some of them include the things we talked about when we were looking at the replication quiz. So one is just common sense. I think this is one that's often overlooked, but just asking, okay, after I read their aims and their research questions and hypotheses, then does the study design, does what they did match those aims? And also comparing what they did to what they conclude, right? So if you look at the method and results, the way they went about doing their research, does that match their aims and their research questions and hypotheses, and does it match the overall conclusion? Like, is that a good way to test that claim or that hypothesis? And another aspect of common sense is, are the results and conclusions believable? So there might be cases that are so extreme where you're just like, there's just no way that that manipulation could have that effect on that outcome or that big of an effect or something like that. One example might be ESP. So one of the things that kind of started off the replication practice in psychology was a paper by the same Gerald Bem that we talked about earlier, who wrote the paper on how to hark. So he had published a paper in 2011 in a top psychology journal claiming that people have ESP. They can see the future. So that on its face is a highly, highly implausible claim. And of course, everyone's subjective probability of how plausible that claim is might be different. Some people might think it's more plausible, some people less, but still that can be a factor in your evaluation of the research. Okay, so from the blog post, one blog post I assigned, here's an example of just using common sense, in addition to some other issues, to critique the validity of a study. So this is from one of the studies and one of the meta-analyses. So the three largest effect size in this meta-analysis about nudging are bananas, and also about bananas. So they all come from study one of this paper, which took place in a Swedish supermarket, looking at interventions at getting customers to buy more organic bananas rather than regular bananas. So they had a confederate, someone who's part of the research team, but the participants don't know it, dressed as an employee of the supermarket, standing 10 meters from the bananas, intercepting customers. After asking, are we going to buy bananas? If they said yes, then they would get one of these 4 messages, which are the nudges. So the 4 messages are, we have environment friendly labeled and non-environment friendly labeled bananas over there, or that's the control one, or our eco labeled bananas are situated right next to our employee standing there. I think that's also a control. I can't remember which ones are the external condition, but the last one is definitely one of the external conditions, saying that the prices are the same. Oh yeah, so I think all 3 of these are experimental compared to the control, and that the sales of organic bananas went up 15, 43, 51, and 51% respectively. That's one too many. I don't know. Maybe those were all interventions and the control was not saying anything. Yeah, that must be it. So this increased the sale of eco-friendly bananas by 15%, 43%, 51%, 51%. And they say that that's just not plausible, partly because the price, anyone who's gonna go buy bananas would likely see that the prices of the two are the same, so it seems shocking that just telling people that would increase their chances of buying eco-friendly bananas by that much. On the other hand, I kind of disagree with them here because I think that there's a strong kind of demand characteristic of pressure, right? People might feel like they're being observed if they know someone just told them and might be watching them. And it's strong, these messages kind of imply that we hope that you'll buy eco-friendly bananas, that's the right thing to do, etc. So those factors, more than the content of the manipulations, to me might suggest that the effects could be that big. It kind of depends what the control group is. So ideally in a control group, there would be someone still approaching them, asking, are you going to buy bananas? At least, right? So that they feel watched. Maybe not saying anything about the environmentally friendly bananas, but at least that much. So they go into a little bit more depth. They say we have two concerns about the study's validity. First, participants are not randomly assigned to the control versus treatment conditions. So they did change the treatment every 30 shoppers in order to counterbalance the effects of time of day and day of the week, and that might be enough to make it close enough to random. But they did not do this for the control condition. So instead, they didn't have a control condition. Okay, so this answers my question about control. I forgot. I made these slides yesterday or the day before. I already forgot. But they compared the 4 experimental conditions to just the sales of the previous week. Now, previous 1 week versus another, there's a huge number of compounds that could affect things there, right? So that's not a good control. They're randomly assigning people, not totally randomly, but changing the treatment condition every 30 shoppers. That seems okay to me. It seems unlikely that something would systematically vary with these 30 shoppers versus those 30 shoppers, especially if you're cycling through all 4 in a relatively short period of time. But the control condition, I could think of a lot of compounds that would affect the sales of the 2 kinds of bananas 1 week versus another. There could be something in the news about why buying eco-friendly products is important, or who knows. So that's a threat to internal validity, as they say. It's a confound between the control condition and experimental conditions. It was different weeks, so lots of other things could have been different in the world, in that shop, in that town, etc. So they give some examples of potential compounds. Their second concern is that the data collection is described with insufficient detail to understand the possible role of compounds, demand effects by the experimenter. So that's one thing I was raising, that having an experimenter there at all talking to you about bananas could change people's behavior, or perhaps more serious anomalies. So given the off-the-charts effect sizes, we believe at least one of these problems is likely present. So they're not giving them the benefit of the doubt. They're saying you weren't transparent enough for me to know if these things might have happened. So I'm going to assume that your study has some threats. So actually, I'm going to go back on what I said. I said that I disagreed with them that these are implausibly large effect sizes. To me, they seem plausible. But what they're saying is that these are implausibly large effect sizes for just the effect of the content of the nudges. And that's what they're interested in, right? They're doing a literature review to understand the effect of nudging. And this, in my interpretation of these effects, is that they're not necessarily effects of nudging, they're effects of someone making you feel bad and watching you buying bananas, right? Making you feel like there's a morally right banana to buy and watching you buy bananas. Maybe you would call that a nudge, but that's not what they're trying to manipulate. That's not how they're describing their research. They're interpreting it as an effect of the content of these nudges. And I agree with the data colada authors that these effect sizes seem very, very large for just the effect of the information presented in the nudge. Okay. So this was their first criticism, that the confound in the manipulation of the control group is a threat to internal validity. And then their second one is that there's not enough transparency. Right? So they're bringing in transparency as an issue. And given that they can see potential problems, that their transparency isn't there for them to know if it's a problem or not, they're going to assume that it is a problem, or at least some of them might be. And then they also use common sense. The off-the-charts effect sizes to them are just not plausible. Okay, here's another example of one where I would just use common sense to be skeptical of the results. So this is a paper that when I made these slides last year, this was just a preprint on medRxiv, but now it's published in a journal. But the screenshots are from the preprint. So it's possible that the final version in the journal is slightly different. So this was a study looking at the impact of the pandemic on early childhood cognitive development from an observational study. So observational study means not an experiment. They didn't manipulate anything. So they argue, this is a justification for the study, that all the effects of the pandemic, the closed businesses, closed daycare, schools, playgrounds, and limited child learning and typical activities, as well as fear of infection and possible employment loss, that's placed stress on parents. And potentially even fear of attending prenatal visits might have increased maternal stress, anxiety, and depression. So there's been concern over how these factors, as well as missed educational opportunities and reduced interaction, stimulation, and creative play with other children, might impact child neurodevelopment. So they ran their study where they tested children on their neurocognitive abilities, and they found cognitive scores were significantly reduced during the pandemic. I don't remember how they got their baseline pre-pandemic measure, maybe based on published studies before the pandemic. They found that the children that they tested had a lower score by 27 to 37 points, almost 2 full standard deviations. P-value is less than 0.01. So first I want to emphasize how big 2 standard deviations is. It's a huge effect. That's very, very noticeable to the naked eye. If you, the average height difference between men and women, I think is less than 2 standard deviations. So if any effect that's 2 standard deviations or more, we probably, and someone paying attention, maybe not me, but someone paying attention would likely have noticed it. And they do have a paragraph in the discussion section about a detail of their method so that they disclose it. They say, one aspect not investigated here is the impact of mask wearing by the study staff during child visits and assessments. The inability of infants to see full facial expressions may have eliminated nonverbal cues, muffled instructions, or otherwise altered the understanding of the test questions and instructions. So during the testing, the staff were wearing masks while they were testing the kids. So testing meant like asking the kids questions that the kids had to answer. There was a right or wrong answer, stuff like that. So to me, this is a pretty major alternative explanation, right? So they think it's COVID and the COVID restrictions or the impact on stress of the parents that affected the children's cognitive abilities. I think it's also very plausible, that sounds plausible to me, but it also sounds very plausible to me that having to do the test with a masked staff member would lower test scores for any number of reasons. So maybe they didn't understand the questions as well. Maybe the facial expressions would have helped them. Maybe the test giver might inadvertently give clues about the answer in their facial expressions, that if there's a mask, they don't get that benefit. Maybe it's just awkward and they were stressed during the testing session because of the awkwardness of the mask. Who knows? So again, we have to make a judgment call here about if we think this is a really big threat and we don't think that this is good evidence to speak to the chances of a cognitive decline in children during the pandemic, or if we think that this is actually probably a minor factor and any decrease is more likely to be due to the stress on parents or whatever other factors they're pointing to. There's not a right answer, and this was not featured prominently in that paper. This was just one paragraph in the discussion section. They don't even present it as a limitation of their study. They just say they didn't investigate the impact of the staff wearing masks, right? That's different than saying that's an alternative explanation. So I think they could have been more upfront about the possibility that some of their effects might be due to this. Here's another one where I think common sense is relevant for critiquing this paper. So this is a paper on the role of ambient temperature, the temperature in the room, and its effect on willingness to pay in auctions and negotiations. So there's several studies in this paper. I'm just going to talk about the first one. So in this study, 70 undergraduate students participated and were randomly assigned to either a higher temperature or a moderate temperature, so 25 degrees or 19 degrees. And then they had to participate in something like an auction, probably a kind of artificial version of an auction. And they found that willingness to pay was higher when temperature was higher. And on average, in a hot condition, people were willing to pay $42.70 on average across a bunch of items. In the 19-degree condition, people were willing to pay $29. This is an effect size of, well, you can see the raw effect size in dollars. In standard deviations, it's 1.5 standard deviations. So Cohen's D is a measure of effect size that changes it into standard deviations. Again, a huge effect, and you can see that already, right? $30 versus $42. That's a very large difference. And so then somebody on social media or PubPeer, I can't remember which, so PubPeer is a website where people can write comments on papers, wrote their critique of the paper. And they wrote an effect of 2 standard deviations, which I think might have been one of the other studies. This one was only 1.5, would surely be noticed by now. And Sophies auctioneers would hold auctions in an optimally uncomfortable 82 degrees, which is 25, I think, or something like that, Celsius. Since this is undergraduate data, not proprietary corporate data, I think it would be helpful if the authors would post the raw data for confirmation. So here they're raising a couple of issues. One is common sense. This effect size seems implausible. You would have noticed it. And another is lack of transparency. They didn't post the data, and there's no reason why they couldn't have posted the data. Since then, apparently the journal has asked the authors for the data. They found some inconsistencies, and the journal has published an expression of concern, suggesting that the data are not accurate, but not necessarily fraud. So it hasn't been retracted. Expression of concern is like one step less than retraction. And they're not saying that there's any misconduct, but that they don't trust the data anymore.
How would, like, I don't understand why it's important, like, the connection between whether it's undergrad data or graduate corporate data.
Yeah, that's a good question. So there are many companies that allow academic researchers to collaborate with them and collect data on the condition that you don't post the data publicly. And that's one of several conditions.
Oh,
Yeah.
okay.
So because this wasn't even a real auctioneer, they didn't even do this in the real world, there's no chance that some outside company is preventing them from posting the data. So that's the point there. There's a whole ethical discussion about whether that's a good reason not to post data, whether we should allow exemptions to data sharing in cases where it's just a company saying, we don't want to give our competitors an advantage, so we don't want you to share the data.
Like just anonymize.
Yeah, but that's the thing, it's not just about, so anonymity is important, and I think we should always anonymize data before sharing. But that's possible to do and still share the data. The issue here is that some corporations will only let researchers publish the results if they don't publish the data, because they're worried that I don't know why, but one possibility is they're worried their competitors could reanalyze the data, discover some insight, and then get a competitive advantage, which is not, that's a completely different interest than what's best for science. So I have opinions about whether journals should allow, like, so the journal that I'm editor-in-chief of, we require authors to post their data if there's no ethical barrier. And so then some authors say, well, there's a barrier, which is that the company that collaborated with us doesn't want us to post the data. That's not exactly an ethical barrier. So then the question is, what do? You allow those exemptions. If you say, no, sorry, you have to meet the same scientific standards as everyone else, if there's nothing in the interest of science or the participants' interests that prevents you from sharing the data. But yeah, opinions differ on that. Okay, so I think that obviously, like, common sense should play a role, but obviously it shouldn't be completely determinative. So we should keep an open mind, and sometimes our common sense is wrong. So it's really this kind of combination of factors. If you see other red flags and it seems implausible, then I would weigh the implausibility more. But if you see something that looks like completely shocking to you, you never would have predicted that, but everything else looks really rigorous, then consider the possibility that your intuition is just wrong. Okay. So then we also should think back to the threats to the four validities. So these are the four validities again. And specifically, so we should critique the measures and the manipulations. I didn't put that here. We should ask if any causal claims are valid here. There's often a lot of this wishy-washy stuff like we talked about last week, where they're not explicitly making causal claims, but they're using verbs that strongly imply causal claims. External validity, asking both about the sample and its representativeness, and about the kind of realism of the study, and does it translate to the context that they want to make claims about. Statistical validity, so if they're using p-values, which almost all social science articles do, or at least in psychology, the vast majority, ask, were the rules of non-cross significance testing followed? So specifically, did they plan a single analysis, or at least if they planned multiple analyses, they had a way to correct for multiple comparisons and follow that plan? And very often you can't know. So the answer, could there have been p-hacking? Almost always the answer is yes, unless it was a registered report or there was a pre-registration, you check the pre-registration, they followed, and you know the plan. Doesn't leave much room for that. Okay, so let's look at another example from the blog. So this is the second study in this meta-analysis. So it's the fourth largest effect size, the three largest are from the banana reviews. So it comes from a study conducted by Mr. Lansing, formerly a full professor at Cornell University, who left academia after an official university investigation found him guilty of many forms of academic misconduct, including data falsification. So these authors of this blog post argue that papers, authored by fraudsters should be treated as invalid unless a co-author actively and explicitly vouches for the validity of that paper. So a different author puts their reputation behind the paper. They reached out to the co-author on this paper asking if they would vouch for the study's validity and shared a draft of the blog post, and that person hadn't responded so far. Okay, so that's a totally different kind of information, right? It's not exact, doesn't fit into the four validities thing, but it's a reason to be skeptical of the quality of the study because, and this is an ad hominem reason. This is something specific to the author. So ad hominem isn't always bad or wrong, in my opinion. There can be cases where using the author's past behavior as a reason for skepticism is relevant. I would have a pretty high bar for that, but I think being found guilty of data falsification is a pretty good reason for that. Now it's tough because often it's the people who might have committed fraud in some papers were also co-authors in other papers, and it might seem unfair to assume that those papers aren't trustworthy. But again, I think this is a pretty good solution that if another co-author comes forward and says, I handled all the data, I collected the data, analyzed it, or I vouched for it myself, then I would believe, trust that paper again. But unless that happens, I think I would be pretty skeptical. Yeah.
This is exactly what is happening with Ariely right now, right?
Ariely, so no, in the case of Dan Ariely, all of the authors have admitted that probably someone changed the data, but no one's admitting to having changed the data. Ariely admits that none of his co-authors had access to the data, but he insists that he's not the one who changed the data. He, at one point, had said that that was the data that were published is what he received from the company that they did the study with, and for a while, the company was not saying anything. And then finally, NPR, National Public Radio in the US, got that company to go on the record and say that is not the data set we sent to Dan Ariely. And in fact, there's more evidence. So they shared the data set they sent to Ariely, and it looks like even stronger evidence now that someone intentionally changed the data. Ariely is still saying it wasn't him, but he's not proposing someone else it could be, I don't think. I just heard that Duke is doing an investigation, so he's at Duke University, they're doing an investigation. So maybe we'll get more information soon. But in his case, he hasn't admitted to fraud, and there isn't an investigation that has concluded that he committed the fraud. In the Francesca Gino case, so she published several papers that there's serious concerns about the integrity of the data. One of those is a different study in the same paper as the Ariely paper. And in that case, she hasn't admitted to fraud, but Harvard did an investigation, published a 1,200-page report. Actually, they didn't share it, but they have a 1,200-page report where they ended up putting her on administrative leave for the next 2 years and asking for retractions of 4 of her papers. So it sounds like they concluded that she committed the fraud in that case. Now she's suing Harvard and these bloggers for accusing her of fraud. So yeah, actually, this is the NPR story about the Francesca Gino case, and includes the paper that Dan Ariely is also on, where there was fraud in that paper. And Michael Sanders, who was the head of the nudge unit in the UK a few years back, he's interviewed in this story and talks about how, based on their research, including the papers that are now retracted, he collaborated with the government of Guatemala to do an intervention to try to increase, I think, ethical behavior in taxpayers. So they did an intervention where they had people sign at the top instead of the bottom, which is what the retracted paper was about. And they spent a lot of money on that intervention and a lot of time, and also they did that instead of doing something else. So there was opportunity costs of doing that. So he talks about how the actual consequences outside of academia of fraud. It's often easy for us to think, oh, who cares if a paper on this silly topic is fraudulent, but there are people facing policy and investing in those findings. Okay, so there's a lot of things. I also want to just remind you about the things that we talked about when we were looking at the details of the replication studies, the replication quiz, the kinds of information we use to critique the methods of the paper. So we talked about sample size, we talked about p-values, we talked about the representativeness of the sample, we talked about selection bias of who might have opted into the study. We critiqued the methods and the manipulations, having potential confounds or just not measuring or manipulating what they say they are. We critiqued the fit between the theory and what was actually done. So that's kind of this match, this common sense match, like they say that expressive writing is good for depression, and then they have people do a 2-minute thing and measure performance. That seems pretty far from the theory, right? All of those critiques were really, really good examples of the kinds of things you would look for when critiquing the validity of individual studies in a lit review. Okay, and then there's calibration. So this is, it kind of overlaps with what we were talking about with validity. It's about whether the conclusions are well calibrated to the evidence. So when there's a big gap between what the claim is and the conclusion and what was actually done, I would put that under validity, but when it's just a matter of degree, I would put that under calibration. So yes, this study can speak to your research question, but you concluded something much more certain or much more extreme than what the evidence you have can support. So that's an issue of calibration. And this is, really hard because it's so common for researchers and articles to exaggerate how strong their evidence is, what it means, what implications you can draw, and so on. And so again, this is something that some journals are trying to curb, but it's really hard because both journals and the authors have an incentive here to make really bold claims. So journals want to publish things with really bold claims because that's what gets more citations, more attention, and the journals are ranked on that. But good editors and good journals should recognize that's not the priority, right? They should not prioritize bold claims and attention at the expense of accuracy. So again, Nature Human Behavior, I should add, I'm not a huge fan of this journal for other reasons, but I do really like their editorial kind of stances on these issues. So they have another editorial published called Not the First, Not the Best, where they say that claims of exceptional quality or significance distract from the actual evidence. So this is when authors make these claims themselves. It reduces the credibility of the research and are best left to readers who are the ultimate judges of value and rigor. So don't tell us that this is super important, it's going to change the world. Let the readers evaluate that for themselves. So they go on to say authors are rightly proud of the work that they do and do want to champion it and increase the probability of acceptance for publication in their chosen journal. However, nobody is the best judge of their own work. And exaggerated claims of importance or rigor can backfire, can actually make you sound less credible, not only when editors and reviewers evaluate a manuscript, but more importantly, when a paper becomes a matter of public record and scrutiny. I think this is very idealistic. I completely agree with these ideals, but I also think that it's if a journal is going to tell its authors, we will hold you accountable for the claims that you make, and if you overclaim, we're actually going to hold that against you, not reward you. They need to really follow through with it. So I'm very curious to see. We won't necessarily be able to tell, but we could look at what kinds of articles this journal publishes in the years to come and see if they're actually doing that, if they're actually holding authors accountable and not allowing exaggerated claims. So I think this is interesting to think about, that researchers want to do incredible research. And I think it's interesting that the word incredible has two meanings. It can mean really great, but it can also mean not credible. And so I think we should care less about being incredible and more about being credible, right? Credibility should be more important. But there are these incentives on researchers and also on journals to make incredible claims. And so it's important to keep that in mind when reading papers. And I would agree with the editorial saying that actually, if you read a paper with really extravagant claims, I would believe everything else in the paper less. If they're kind of uncalibrated in their conclusions, they're going too far in their conclusions, then they're giving themselves permission to act in a way that's not very scientific. And I would trust them less in every other area of their research as well. A little bit less. So I would consider all of these things. If they're not transparent, I wouldn't just give them the benefit of the doubt and trust that everything they did was good. I would assume that if I had more information, I would be able to detect other problems, other threats to validity. Then I would look at threats to validity, depending on my level of expertise in that particular domain, I might be able to see them or I might not. So it sometimes can be hard, but there's also things like common sense and some very basic threats, things like looking at the p-value, et cetera, that you don't need a lot of expertise to be able to calibrate your confidence. And again, none of these are on their own, like absolutely you should always ignore a study if it has a high p-value or a small sample or anything like that. There's always some judgment call to be made. And then I would look for signs that the researchers are well calibrated and committed to accuracy, looking at how much hyper exaggeration there is in their interpretations. Okay, so to summarize, I would say be skeptical when researcher isn't reported transparently. So if you can't tell what they did, you wouldn't be able, or a researcher with the resources wouldn't be able to repeat what they did from scratch. If the data aren't available and there's no good reason given, and again, we talked a little bit about what counts as a good reason, like if it's proprietary data, maybe they really are bound by that, so at least that's a reason. Sometimes there are good ethical reasons why data can't be shared. Or if you can't tell what was planned and what wasn't. So if they're basically asking you to take their word for it, that this was the hypothesis they had all along, and this is how they plan to test it, and so on. Or you can't tell if there might be entire studies that were not reported or entire parts of the design. Sometimes people drop a condition in their study and don't report that. Be skeptical if the methods are weak, or maybe they're not just objectively weak, but they're weak for the purpose that they're using them for. So measures or manipulations that are invalid or mismatched to the aims and interpretation of the paper. A sample of participants that is bad in many ways, so it could be too small, it could be unrepresentative, or it could be a very good sample for question X, but not the appropriate sample for their research question. And then casual causal inference, so this is, causal claims when they're not warranted or when there are threats that aren't acknowledged, etc. And I would be skeptical when authors make exaggerated or grandiose claims because of what that signals about their commitment to accuracy. Okay, that's actually all I have for this week. Are there any questions, anything that people want to review before this is my last time seeing you all? Anybody have anything unclear? All right, well, feel free to email me if anything comes up, and it's been great teaching you all, and yeah, hope to cross paths again.